Across the United States and many other parts of the world, a simple plant grows quietly along roadsides, in fields, and even in neglected ditches. Most people walk past it without a second thought. Some pull it out of the ground and toss it aside like a useless weed. Yet hidden inside this ordinary plant is a power that could transform dirty, contaminated water into something far cleaner and safer to drink. The plant is known as Moringa oleifera, and its seeds contain a natural purification ability that scientists have measured, tested, and confirmed for decades. In controlled studies and real-world trials, this humble plant has shown the ability to remove bacteria, viruses, sediment, and other contaminants from water with surprising efficiency. In fact, in many cases, it performs even better than expensive filtration systems that cost hundreds of dollars. The story begins long before modern water filters ever existed. In the early 19th century, during the expansion of the British Empire into India, a military surgeon named James Kempthorne faced a deadly problem. His soldiers were stationed in remote regions where clean drinking water was almost impossible to find. Streams and rivers looked clear, but they carried invisible threats: bacteria, parasites, and diseases that spread rapidly through camps. Dysentery, cholera, and other waterborne illnesses killed more soldiers than battlefield wounds. Kempthorne searched desperately for a solution, but the medical knowledge of the time offered very few answers. Local villagers eventually introduced him to a tree that had been part of their traditions for generations. They collected the seeds from the tree, removed the outer shell, crushed the kernels into powder, and stirred the powder into containers of muddy river water. At first, the mixture looked cloudy and strange, but within less than an hour, something remarkable happened. The suspended particles began clumping together, growing heavier and slowly sinking to the bottom of the container. The once brown water gradually turned clear. Kempthorne recorded the results carefully in his field notes. When the treated water was tested later, bacterial levels had dropped dramatically. It was a simple method, yet incredibly effective. Despite the promise of this discovery, the information was filed away and largely forgotten. More than a century passed before scientists returned to study the plant again. In the early 1980s, researchers began analyzing moringa seeds in laboratories and field trials. What they discovered explained why the seeds worked so well. Inside the seed are specialized proteins that carry a strong positive electrical charge when dissolved in water. Most harmful particles suspended in water, including bacteria and viruses, carry a negative charge. When the seed powder is mixed into contaminated water, the positively charged proteins immediately begin attracting those negatively charged contaminants. At the microscopic level, this attraction causes particles to stick together. The contaminants bind to the proteins and form larger clusters through a process scientists call flocculation. As the clusters grow heavier, gravity pulls them down to the bottom of the container. This leaves the water above significantly clearer and far less contaminated. The same scientific principle is used in large municipal water treatment plants around the world. The difference is that industrial facilities rely on manufactured chemicals like aluminum sulfate to trigger the coagulation process. Those chemicals must be produced in factories, transported to treatment plants, and used continuously. They also create chemical waste that must be managed carefully. Moringa seeds achieve a very similar result using a completely natural process. The tree grows rapidly in warm climates and can produce thousands of seeds each year. The seeds require no industrial manufacturing, no expensive machinery, and no complex supply chains. In many regions, the tree already grows naturally, making it an accessible and renewable resource. When international organizations began studying its potential more closely, the results were striking. Experiments using heavily polluted river water showed dramatic reductions in turbidity, bacterial contamination, and suspended solids after treatment with crushed moringa seeds. Researchers measured drops in bacteria counts approaching 99% in some trials. Murky water from rivers and flood zones became visibly clearer after a short settling period. The effectiveness was strong enough that global health organizations began discussing the plant as a possible low-cost solution for communities lacking access to modern water infrastructure. In areas where expensive filtration systems were unrealistic, the ability to purify water with locally grown seeds offered a powerful alternative. Yet despite the scientific interest and decades of documented research, the method never became widely known in many developed countries. Instead, the market for water purification became dominated by a different approach: commercial filtration products. Over time, a large industry developed around selling portable filters, cartridges, replacement membranes, and purification devices. These systems can be effective, but they often rely on ongoing purchases to maintain performance. Filters must be replaced, cartridges eventually wear out, and new units must be bought when the old ones fail. The existence of a plant that could assist in purifying water without complex equipment did not fit easily into that model. Unlike manufactured products, a tree cannot be patented in the same way as a proprietary filter design. Seeds can grow, reproduce, and spread naturally. Anyone with access to the tree can collect them and prepare the powder themselves. Because of this, the idea never received the same level of commercial development or marketing attention as high-tech filtration products. For people living in remote environments or emergency situations, however, the technique remains valuable knowledge. Preparing the seeds for water treatment is relatively simple. First, the dry seed pods are opened and the kernels inside are removed from their shells. The kernels are then crushed or ground into a fine powder. A small amount of the powder is mixed with a little clean water to create a paste. This paste is stirred vigorously into the contaminated water for several minutes, so the proteins disperse evenly throughout the liquid. After the initial mixing stage, the water is stirred slowly for several more minutes. During this period, the flocculation process begins as particles start bonding together. The container is then left undisturbed so the clusters can settle naturally to the bottom. Within roughly half an hour, the difference becomes visible. Sediment and contaminants gather below, while clearer water forms above. Carefully pouring off the upper portion into a clean container separates it from the settled debris. Although this process removes a large portion of contamination, additional safety measures are often recommended. Boiling the treated water provides an extra level of protection by destroying any remaining microorganisms that may not have been captured during the settling stage. When both methods are used together, the resulting water can be significantly safer than untreated sources. The story of Moringa oleifera illustrates how powerful solutions can sometimes exist in the most ordinary places. A plant growing quietly in fields and roadsides carries within it a natural system for improving water quality, a system understood by traditional communities long before modern chemistry explained why it worked. Scientists eventually confirmed the mechanism, documenting how charged proteins interact with contaminants and cause them to settle out of the water. Today, the tree continues to grow in tropical and subtropical regions around the world. Its leaves are used as nutritious food, its seeds can produce oil, and its natural purification ability remains an important tool for communities seeking affordable ways to improve water safety. What was once dismissed as a simple weed has proven to be far more remarkable, demonstrating that sometimes the most overlooked resources can hold solutions to some of humanity's most basic challenges.